Hello guys, pagpatuloy lang natin yung ano no, yung discussion natin na nakaraan. So, nasa thermal properties of matter pa rin tayo. And this is the fourth subtopic, yung heat capacities. Okay? So, let's start with heat capacities. So, dito meron tayong tinatawag na heat capacities of gases. So, the basic of our analysis is that heat is energy in transit. Okay? So, when we add heat to a substance, we are increasing its molecular energy. Yun. So, kapag iniinit daw natin yung isang bagay, nagbibigay tayo ng molecular energy para doon. No? In this discussion, the volume of gas will remain constant. So, magiging constant yung volume natin dito. So that we don't have to worry about energy transfer through mechanical work. If we were let the gas expand, it goes to work by pushing on moving walls of its container. And this additional energy transfer would have to include in our calculation. So, balik tayo sa more general case natin. No? For now, with the volume held constant, we are concerned with the CB or the molecular heat capacity at constant volume. Okay? So, in the simple kinetic molecular model, energy consists only of the transitional kinetic energy na KTR. No? Yung KTR natin. Ayan. Of the point-like molecules. So, this energy is directly proportional to the absolute temperature or yung tinatawag natin na T. So, meron tayong equation last time, 'di ba? Yung equation na K TR is equal to 3/2 nRT. Yan. So, dito makikita natin na yung KTR is directly proportional to T. Okay? When the temperature changes by small amount of dT, the corresponding changes in kinetic energy. So, kapag dinerivative daw natin yung T, magkakaroon din dito ng pagkakaiba. So, magiging D derivative of KTR is ngayon magiging 3/2 NR dt. Ayan. So, from the definition of molar heat capacity at a constant volume, CB. Okay? So, magiging dq. Uy, pagpasensya niya yung umiiyak sa likod, ha? NCB dt. Yan. So, where dq is the heat input needed for a temperature change ng dt. So, now, if KTR represent the total molecular energy, as we assume na yung dq and dtr, we must be equal. No? So, ang mangyayari dito, i-equate natin yung ito dito. Dito. Okay, so mangyayari is, dahil nga d k tr is equal to dq, ang mangyayari is 3/2 nr dt is equal ngayon sa ncb dt. Okay? Wait lang. Mali yung dt ko dito. Dt to. Okay? So, ayun, makaka-cancel out ngayong n. Yung dt, cancel out na. No? And ang mangyayari dito is cb equals to 3/2 r. So, ngayon, yung formula ng ideal gas of point particles. Okay? So, makikita natin yan dun sa ating presentation. Ayan. These surprisingly simple results say that the molar heat capacity at a constant volume na 3R over 2 of any gas whose molecule can be presented as point. Okay? So, this equation agree with the measured values of molar heat capacities na yung SI, no? So, magiging ganito siya. Magiging CB is equal to 3 over 2. No? Tapos yung constant natin R na 8.314 joule. Or magiging, pag minultiply natin yan, magiging 1237. Ayan. Yun yung magiging CB natin ngayon. So, this comparison, no? Ito pala guys yung tinatawag nating motion of diatomic molecule. So, meron tayong transitional motion, meron tayong rotational and vibrational. Okay? So, ito naman yung formula natin ng diatomic gas including rotation. Ayan. So, imbis na 3 over 2, magiging 5 over 2 siya. Ayan. Pakitake note na lang yan. Okay? So, pasok tayo dito sa tinatawag na heat capacities of solids. So, we can carry out a similar heat capacity analysis for a crystalline solid, no? Consider a crystal consisting of an identical atom or a monatomic solid. So, each atom is bound to an equilibrium position by enantiomic forces. So, the elasticity of solid material show us that their forces must permit stretching and bending of the band. So, we can think of a crystal as an array of atom connected by little spring na makikita na dati dito sa figure. So, each atom can vibrate about its equilibrium position. Okay? So, each atom has 3 degree of freedom. Corresponds to the 3 component of velocity. So, kunwari nandito, yung atom, meron siyang 3 na freedom. Okay? So, according to the equipartition principle, each atom has an average kinetic energy of 1/2 kT. Okay? Meron daw average kinetic energy na 1/2 kT. Yung kada atom. So, in addition, each atom has potential energy associated with the elastic deformation. So, for a simple harmonic oscillator, it is hard to show that average kinetic energy of an atom is equal to its average potential energy. So, sa model natin, ito yung model natin ng crystal. Each atom is initial a 3-dimensional harmonic oscillator. Ito. It can be shown that the quality of average kinetic and potential energies also holds true provided the spring forces that nag-o-obey doon sa Hooke's law. So, kung di kayo familiar sa Hawk's Law, ito yung ginagamit sa strength of material, no? So, maano nyo to, madadaanan nyo to sa strength of material nyo. So, thus we expect each atom to have an average energy of 3 over 2 kT in an average potential ng 3 over 2 kT pa rin. Or an average total of 3 kT. Okay? So, if the crystal contains n atoms or number of moles or n moles, its total energy is magiging E total na pati. E total is equal to 3 n kT or magiging 3 n RT. Okay? From this, we conclude that the molar heat capacity of a crystal could be CV over 3R. So, ito yung tinatawag nating monoatomic solid. Ideal monoatomic solid. So, kung papasok natin yung value ng R dyan, magiging CB equals to 3 multiplied by 8.314 joule, mole, Kelvin. No? Or this is equal to 24.9 J mole Kelvin. Okay? Ito yung magagamit natin kapag nasa SI tayo. So, dito meron tayong tinatawag na rule of Dolong and Petit. Okay? Na may encounter natin doon sa empirical finding. Okay? So, elemental solid all have molar heat capacities of about 25 joule per mole. So, yung mga mga solid daw is merong molar heat capacity. Merong molar heat capacity na 25 joule per mole. So, now we can have derived that the rule of the rule from kinetic theory. The agreement is only approximate to be sure but consider the very simple nature of our model. Okay? So, pasok tayo sa last topic natin dito, no? Hindi ako nagkakamali. This is the last topic, yung molar speed. So, as we mentioned in a section nung, kanina, the molecule in a gas don't all have the same speed. Okay? So, itong figure na to is nagpapakita ng experimental scheme of measuring the distribution of molecular speed. Okay? So, meron siyang vacuum chamber, meron siyang fast-moving molecule from oven, no? Tapos, slits make a narrow beam for a molecule. Tapos, sa dulo, merong motor saka detector. So, kapag yung substance dito is mag-evaporize dito sa hot oven natin, the molecule of the vapor escape an aperture in oven wall and into the vacuum chamber. So, kapag ininit daw natin yung isang substance dito, mag-evaporate siya. And yung molecule na yon is mag-escape dito sa butas na to, papunta dun sa vacuum. So, a series of slits blocks all molecule except those in a narrow beam, which is aimed to pair of the rotating disk. Okay? Itong rotating disk na to. A molecule passing through the slits in the first disk is blocked by the second disk unless it's arrived just as the slits in the second disk is lined up with the beam. Okay? So, that is function as a speed selector that passes only molecule with a certain narrow speed range. So this range can be varied by changing this rotation speed, and we can measure how many molecules like within each various speed ranges. So to describe the result of such measurement, we define a function na f of b. No? Magkakaroon tayo dito ng f of b na tinatawag nating distribution function. If we observe the total molecular and the number of dn, no, magkakaroon tayo ng dn, number of molecule, having speed in ranges from b and b plus dab. So ito pala is paganto para hindi tayo nalilito. Velocity to. So dito makakapag-formulate tayo, no, na yung ano daw natin, yung derivative of n is equal to n, yung distribution function natin, dv. Ayan. So we can also say that the probability that that a randomly chosen molecule will have a speed and interval of b to b plus db is distribution function multiply the derivative of b. So hence, ito daw is the probability per unit speed interval. And it's not equal to the probability that a molecule is sped exactly equal to b. Since the probability is pure number, no? And this distribution factor has units of reciprocal of speed, or yung tinatawag natin na second over meter. Okay? So, if we know na yung distribution factor na FB, we can calculate the most probable speed na BMP, the average speed na yung speed average natin, and the RMS speed. Okay? We simply find the point where the df over dw equals to 0. This is given that the value of speed where the curve has its peak. Okay? Okay, so dito magkakaroon tayo ng yung average speed natin or yung B average is equal to the integral of V tapos yung distribution function natin dV from 0 to infinity. Okay? So, the RMS speed is obtained similar, no? The average of B squared is given by this equation. So, ganito siya. Average is equal to the integral of 0 papuntang infinity. B square tapos distribution function dB. Ayan. So, yung BRMS naman is the square root of this. Okay? So, ito naman si Maxwell-Boltzmann distribution. So, the function of BF describe the actual distribution of the molecule speed is called the Maxwell-Boltzmann distribution. It can be derived from a statistical mechanics consideration, but that derivation is beyond our scope, no? So, ito yung naging result niya. Okay? So, i-take note nyo na lang to. So, we can also express this function in terms of transitional kinetic energy of a molecule, which denoted by epsilon or yung letter E, yung ganitong symbol. Ayan. So, magiging epsilon equals to 1/2 mv square. So, maaano natin to, mabe-verify natin to kapag sinubstitute natin yung Maxwell-Boltzmann distribution dito. Okay? So, pag sinubstitute natin yan, kasi i-rewrite nga natin yung Maxwell-Boltzmann. So, yung Maxwell, dito na tayo sa next para malinis. So, yung Maxwell-Boltzmann is distribution factor is equal to 4 pi m over 2 pi kt. Ito is naka-raise sa 3 over 2. Speed square or b equals to e mb square over 2 kt. Okay? So, pag ipinasok natin yung epsilon equals to 1/2 mb square, ang mangyayari ngayon is fb or distribution factor equals to 8 pi over m. T over 2 na to. Tapos dito ni epsilon. E raised to negative epsilon over kt. Ayan. Napakahabang formula. So this form show that the components in Maxwell-Boltzmann distribution function is negative epsilon over kt, and the shape of the curve is determined by the relative magnitude of epsilon and kt at any point. We leave it to you, no, na ma-prove natin yung peak of each curve occurs when epsilon kt, no? Okay. So, pasok tayo sa number 6. So, ito pala guys yung fractional molecule, yung ideal gas with the less of various multiple. Okay? So, dito tayo sa phases of matter. So, an ideal gas is the simplest system to analyze from a molecular viewpoint because we ignore the interaction between molecules. But those interactions are the very thing that makes matter condense into the liquid and solid phase under some condition, no? So, it's not surprisingly that theoretically analysis of a liquid in a solid structure and behavior is a lot more complicated with the gases. We won't try to go far with here with a microscopic picture, but we can talk in general about phases of matter, phase of equilibrium, and phase transition. So, makikita nyo dito yung tinatawag natin na typical PT phases diagram na nag-show ng temperature and pressure at which the various phases exist and where phases change occur. So, doon sa first topic natin, pinakauna natin topic na tutunan natin yung each phases is stable with a certain ranges of temperature and pressure, no? So, a transition from one phase to another ordinarily requires yung tinatawag na phase equilibrium. So, between the two phases, and and for a given pressure, it occurs at only one specific temperature. Okay? We can represent this condition in a graph na tinatawag natin yung PT. PNT called the phase diagram na makikita nyo dito. So, shown on example, each point on the diagram represent a pair of values P, pressure, and temperature. So, dito din yung vapor, no? Pag mataas ang temperature, dito naman yung solid siya, nandito naman yung kapag liquid siya. Okay. So, only a single phase can exist at each point. So, na makikita nyo dito. So, except for the points on the solid line where two phases can coexist in equilibrium. Okay? The fusion curve separate the solid and liquid areas and represent the possible condition of the solid-liquid phase equilibrium. Dito, solid-liquid. Okay? Ito yung tinatawag natin yung fusion curve. So, the vaporization curve naman, yung nandito, separate naman yung liquid and vapor areas. And the sublimation curve naman, ito, na nagse-separate naman sa vapor and solid. Okay? So, all the three curve, nagmi-meet sila dito sa triple point. The only condition under all the three phases coexist. Okay? So, triple point temperature of water to define the Kelvin temperature scale. Okay? If we add heat to the substance at a constant pressure na PA, it goes through the series of state represented by horizontal line. Okay? Dito. Itong line A na to. Ayan. The melting and boiling temperature of this pressure are the temperature at which the line intersects the fusion of the vaporization curves respectively. So, when the pressure is PS, nandito, okay, yung PS, constant pressure heating transfer of a substance from solid directly to the vapor. Yung nandito, no? Kapag nasa PS pala tayo. This process is called sublimation. Okay. The intersection of line S with the sublimation curve gives the temperature Ts. Okay? Yung Ts na temperature natin. At which occurs the pressure Ps. At any pressure less than the triple point pressure, no liquid phase is possible. Though the triple point pressure of a carbon dioxide is 5.1 atm at normal atmospheric pressure. Yung solid carbon dioxide naman, yung tinatawag nating dry ice, nag-undergo siya ng sublimation. So, kung familiar kayo dun sa dry ice, no? Hindi natin siya makikitang mag-melt. So, from solid phase, nagiging vapor kagad siya. So, yun yung nagpo-produce ng napaka-kapal na usok. So, wala tayong makikita na liquid phase, no? So, dito naman sa line B, itong line na to, ito naman yung nagpe-present ng compression at constant temperature TB. Okay? So, the material process from vapor to liquid and then solid at the point where line crosses the vaporization curve and the fusion curve. Okay? So, respectively, yung line D naman show a constant temperature compression and a lower temperature DT. Dito. So, the material passes from vapor to solid at the point where line D crosses the sublimation point or sublimation curve. So, dito makikita natin sa PV diagram that the liquid vapor phases transition occur only when the temperature and pressure are less than those the 2-point line at the top of the grain shaded area. So, liquid vapor phase equilibrium. Okay? So, ito naman, makikita natin yung triple point data. Okay, ng hydrogen, deuterium, neon, nitrogen, oxygen. So, ayan. So, makikita nyo rin to dun sa book nyo. Okay? So, and that's the end of my presentation about doon sa second topic natin sa thermodynamics. Okay? And guys, please note that lista nyo lahat ng hindi nyo naintindihan dito para ma-discuss natin sa ating synchronous. Okay? Sige. Thank you so much and goodbye.